Hello everyone. Today we have again meet here for this our discussion. Continue our discussion on some of the important additional topics of this introduction to organic chemistry and basically basics of organic chemistry. So in all of this context, generally we have seen majorly this some of the last sessions we have seen what are the van der Waals interactions, van der Waals forces, bonds which are essential in non-polar molecules. Majorly non-polar molecules are the kinds of the molecules which can make non-polar van der Waals kind of interactions. So that we have seen that when the molecules are far from each other, they are having no interactions or least interactions. Are closer to each other, the interaction increases. They come closer, further there is enhancement in the interactions of van der Waals force. Further, if they come closer, this van der Waals interactions will be maximum. And the distance between these two atoms is equal to the van der Waals radii, then in that case, this distance is also increasing. But then even we try to bring the molecules closer, then their attraction will convert into the repulsion. Attractive force will behave after that distance as a repulsive force. Okay. So we have seen all of these kinds of interactions. Hydrogen bonds, a kind of bond which can be formed between electronegative atom and the hydrogen atom. We also seen that how the bond formation, hydrogen bond formation can be possible in a water molecule, in ammonia molecule, as well as in hydrogen fluoride. Other bond we have also seen, covalent bond. This is a kind of bond formed because of the sharing of electrons. And this bond, what is called ionic bond. So several kinds of interactive forces we have seen in some of the last sessions. So today is a dedicated session for us to refer to the several isomers. Today we are going to learn which are essential. As we know that isomers are the molecules which are having the similar formula but having some different structure. Okay. So there are several types of isomers are available. Having similar molecular formula but different kind of the structure. Okay, so in this regard, we need to visit the structural framework of all of these isomers. Okay, so what are these isomers? So let us start first with our these isomers. So iso that is one word and mer is another word. Iso means basically the dictionary meaning of iso that is same. Okay, iso is same. This mer basically which stands for a particular wheel, we can call it as molecule, right? So they are the same molecules, isomers. They are the same kind of the molecules. इसलिए जो आइसोमर होते हैं ना वो they belongs to particular one kind of compound, but structures are different. If structures are different, then definitely compounds are also different. but some way they are having common molecular formula. You know what is called molecular formula, which is ultimately responsible for creating molecular weight. Okay. Molecular weight will be same because molecular formula is also same. Molecular formula, molecular weight, isomers are same. The molecules can have molecular formula, molecules can have molecular weight. So these two properties which are same. However, these substances have a different type of property. That is their chemical structure. Chemical structure of all these compounds are different. We need to identify that how these molecules can have different chemical structures, a kind of different bonding with each other. Okay, so there are so many examples the way these isomers are known. They are the molecules having the similar molecular formula but having the different chemical structure. So let me show you how these molecules can have a different kind of chemical structure. That I am going to show you through the several classifications of isomers. Okay, so now we shall be shifting for another, after the definition of isomers, we shall be shifting to learn the topic, that is classification of isomers. Okay, so here it is. What is the classification of isomer? How the way isomers are known? How what is their basic many other properties? Classify. We have to classify the isomer, just like you people are classified. From the first year, from the second year, from the third year, and from the fourth year. So teachers are different, syllabus is different, and parallelly so many sessions are going on all the years. So you are is also one kind of class from the first year. So isomers can be also classified depending upon their unique properties. Those who are having similar for properties, let us group them into particular one class. Those are having different property, they should be grouped into other class. This way, isomers are classified. So we have a concern for this, how to classify the isomers. What should be their genesis of classification? The genesis is the definition by itself. So isomers are generally can be classified into so many types which I'm going to show over here. So the first type of this is basically here. We can classify the isomers into two different types. Okay. So number one here is constitutional isomers. So we can classify the isomers into the first type, that is constitutional isomers. So what is called constitutional isomers? These are the isomers which are having constitution is different. Their structures are different. They are differently constituted. That's why they are termed as constitutional isomers. We will see the examples of these constitutional isomers. Sometimes these kinds of isomers are also called as functional group isomers because their functional groups are different. So constitutional isomers functional group isomers. Both of them have their different kinds of functional groups present into these molecules. I can give the example for this. For example, any alcohol and ether. Number one among this is alcohol, ether. Alcohol and ether are having common functional groups, but molecules will have a common molecular formula. But however, the molecules have different chemical structure. You may remember the example of ethanol. Molecular formula is CH3, CH2, OH. Okay, so this is alcohol. But ether, CH3O, CH3, methoxymethane, ethanol, both are having same number of carbon, hydrogens, and oxygen. So these kinds of more structures are termed as, these kinds of isomers are called as constitutional isomers or functional group isomers because their functional groups are different. These structures are different with respect to the handle of the molecule. Those functional groups are generally termed as the handle of the molecules with the help of which we can control the reactivity of the molecule. So that's why they are functional group isomers. Okay. Then another kind of isomer which we can have is aldehyde. And along with aldehyde, we can have ketone. So they are also this kind of isomers. So aldehyde as well as ketone. So if I give this example, so you may consider simple two carbon containing aldehyde, that is formaldehyde. Sorry, acetaldehyde, CH3, CHO. And no, aldehyde and this cannot be possible. I'm sorry for the same aldehyde. I wish to say cyanide and isocyanide. Okay, so this can be another way. It is possible. Cyanide and isocyanide. For example, if we have, let us say, CH3CN, and you know isocyanates are the molecule which are having CH3NC. So cyanide is basically nitrile. Isocyanate where nitrogen is positively charged and having a particular carbon. Cyanide as well as isocyanate. So this way, alcohol and ether, cyanide and isocyanide, so they are functional group isomers. Because their functional groups are different, but they are having common kind of structure. So this is basically for a kind of constitutional isomers. Okay. And similarly, I was on the right point to discuss. We can have other examples also. For example, I draw the molecular formula of CH3, CO, CH3. This is nothing, but it is our acetone. So this acetone may have similar molecular formula CH3, CH2, CH2. What is it? It is 3 carbon containing ketone, 3 carbon containing aldehyde. Okay, so aldehyde and ketones are also these kinds of compounds, which was I was telling just before a few minutes. Aldehydes and ketones, they are also functional group isomers of. Okay, so they are also called as constitutional isomers. So this functional constitutional isomers, functional group isomers are classified as, for examples are alcohol and ether, another example is cyanide, isocyanide, and third example is aldehyde. You can refer these molecules are having different functional group. Ketone and aldehyde both have different physical or chemical reactivity. We can say some compounds give tolerance taste, some compounds do not use to give this kind of the taste. Okay, so we have seen all these kinds of properties in the molecules. With respect to that, these are the we generally wish to say that molecules can have different properties depending upon several kind of this wish to we can claim these molecules as constitutional isomers, functional group isomers. What is their functional groups are? Now I might have given here one or two examples. आप एक एक कार्बन इसमें बढ़ाते जाओ. Instead of giving the example of 2 propanol and propionaldehyde, you may give the example of 2 butanol, butyraldehyde, or let us say then 3 pentanol, pentanaldehyde. All of them belongs to this homologous series of several isomers. Molecules which are having similar formula, molecular weight, but having different chemical structure. So these all isomers have that different chemical structure. The chemical structure of ketone is carbon doubly bonded with oxygen, and aldehyde is carbon is there, but it is having hydrogen as well. In case of ketone, it may be two alkyl groups. So that way, constitutional isomers are known. Then after this constitutional isomer, another type of isomer which is called as configurational isomers and conformational isomers. पर उसका जो major type है, that is stereoisomers. So this stereoisomer is a huge number of isomers are covered under this topic. I'm going to teach you that also. And the occurrence of this isomer that is called as isomerism. Phenomena, the process, the occurrence. These molecules can exist in the form of isomers, so that is called as isomerisms. But isomers are the molecular structures having similar molecular formula, molecular weight, but different chemical structures. So what are called stereoisomers? So friends, these stereoisomers, they are a kind of isomers. But what is the meaning of this stereo? Stereo is a word which means three dimensions. Three dimensions means you know if I say one dimension, simply this is a point. Okay. ગુજરાતીમાં આપણે કહીએ તો બિંદુ. અવ્યાખ્યાયિત પદ. We cannot define it. This point. But if 2 points are there, connect the points using a line. Will make one dimension. It will create a line. ગુજરાતીમાં કહીએ તો રેખાખંડ. Let us draw one more point. And connect this two with the new one. Now it is a two line, but they have created some angle. Maybe it is the angle where Pythagoras has given his principle. Okay. So we to calculate that lateral phase from the two different phases. AC square is equal to AB square plus BC square. Fine, we'll not go into the mathematics because we are learning the chemistry. So this point is now converted into a new angle, new shape that is called angle. And then let us draw one more point. Connect these two dots ends with the new one. Is now square. We used to call it as a shape. Line, a dot, line, angle, shape. And the shape is square. It can be rectangle, it can be triangle, or it can be circle, or it can be hexagonal, heptagonal, pentagonal, whatsoever. These are the shapes. पॉइंट से शुरू किया था शेप तक पहुंच गए બિંદુથી શરૂ કરી હતું અને આપણે આકાર સુધી પહોંચી ગયા okay so then this shape if it is this is called two dimension only two dimension પહોળાઈ લંબાઈ they only two length and breadth these are the two dimensions a third dimension જેને ગુજરાતીમાં કહીએ તો ઊંચાઈ length breadth and depth. So three dimension, x-axis, y-axis, z-axis, length, breadth, and depth. So that way, this can be a shape like this. It's a cubic passos. મામા શકુની ને જે રમ્યા હતા ને એ શતરંજ સાપસીડીમાં જે પાસો રમો છો એ cubic kind of dice used for playing these games, indoor games. Okay, so now this cubic is in three dimension because it is having length, breadth, and depth. So stereoisomers are the molecules which differ from each other in three dimensions: length, breadth, and depth. લંબાઈ, પહોળાઈ, અને ઊંચાઈ. That way, these molecules can exist. Three dimension means you might have heard something a 3D movie. This stereo basically means because of COVID-19 we cannot go. We now maybe cinema and these theaters are open, so we can go there and can watch the movie, maybe a 3D movie. So if our institute is sponsoring a movie to watch to all of you free of cost, and the option is whether you want to go for 2D movie or whether you want to go for 3D movie. You will prefer to go for 3D movie. You will avoid 2D movie. दो टू डायमेंशन में आपको उतना एक फील नहीं होगा, उतना एक्सपीरियंस नहीं होगा, उतना रियलाइज नहीं होगा जितना आपको 3D में होता है. 3-dimensional you will prefer. Salem College of Pharmacy is sponsoring a 3-dimensional movie for you people. So stereo basically that means 3D, 3 dimensions, x, y and z. उसी से ही आप देखो ना, तो ये जो आपका x एक्सिस, इसको बोलो x, इसको बोलो y, तो z axis will be here, x axis, y, here it will be z. So these three axes where the molecule is defined to exist in 3 dimensions. So these are the isomers called as stereoisomers. The isomers which differ from each other in 3-dimensional space. In 3 dimensions. I hope that I am able to make you clear what is called a 1 dimension, 2 dimension, 3 dimension. With this example, 1D, 2D, and 3D. will be clear. So, stereoisomers is not kind of class of one or two miscellaneous examples, one or two examples. These stereoisomers having so many types, so that we have to see first that what are these stereoisomers, how they differ from each other. So we will go into the depth of this to refer to this classes of stereoisomers, the subparts, the other types of these isomers. So stereoisomers, they are classified into two major types. I'm going to draw further classification of stereoisomers. Number one, what is called this conformational isomers. Okay. So these isomers are generally termed as conformational isomers. Other isomer is called as configurational isomers. Two types of isomer are there: conformational isomers. Now we will come to these two, both of the terms. We know about the philosophy of this two different isomers. So let me introduce you first for conformational isomers. These conformational isomers, basically they are also called as conformers. These conformers are different from the terminology called to conform. Okay. So that is different. To confirm means to decide, to fix, to make the decision. That is to confirm. Here is a difference. Confirm and this conform is different. There is only difference of I versus O. So that is not here. So don't do the mistake. That is to confirm means to fix, to decide, to make a decision. Here it is conform. Generally, two carbon atoms which are connected with each other, they can rotate across the carbon-carbon single bond. For example, these are the two carbons. They are connected through a single bond. So now they can rotate like this. That is actually called as conformers. In your some of the practicals, we shall be having demonstration of some of the stereo models where we can show these conformers. Basically, when I will come in the next class, I shall try to show that models virtually so that you can educate yourself with these terminologies. So conformers, which are the isomers, differ from each other due to rotation across carbon-carbon single bonds. This can be the examples in butane. We know several types of these isomers and their examples are available. For example, it can be gauche, or let us start from it is fully eclipse. You might have heard somewhere this previously. So we are continuing that. It may be gauche, gauche, okay, gauche, we will pronounce it gauche. It can be partially eclipse, fully eclipse, gauge, partially eclipse. It can be anti or staggered. These are the four conformers: eclipse, fully eclipse, partially eclipse, gauge. Sometimes it is also called as either gauge or it is also called as skew. Gauge or skew. Both are same. These are the main four types of these conformational isomers: fully eclipse, gauge, then partially eclipse, and then anti or stable. They are the four types of. How they differ from each other, that we will see in the coming discussion. So let us see what are these types of conformers, etc. Then configurational isomers. Let us discuss this first. Configurational isomers. So friends, these are the isomers which are having difference from each other with respect to their configurations. Okay, so they differ from each other from their configuration. Fine. So this is here I actually just have forgot to discuss with you. So here these all are equal for acyclic compound. Acyclic. This is for acyclic one, conformational isomers. And conformational isomers are also available for cyclic compounds as well. So here I mean to say cyclic one. So all these belongs to cyclic, this belongs to acyclic, and this belongs to cyclic. Cyclic maybe there are examples. So what are they? This can be number one, can be boat, can be second, it can be chair, third, it can be half chair, fourth, it can be half boat. Okay. So these are the four examples: cyclic, conformational, stereoisomers, isomers. So boat is a cyclic, conformational, stereoisomer. Anti or staggered belongs to acyclic, conformational, stereoisomers. Half chair belongs to cyclic, conformational, stereoisomers. How what is called boat, what is called chair, half boat? Hold these questions. We are going to learn this in our coming discussion. Then now let us go to the configurational isomers. The isomers which are having different constitution and differ from each other. What can be this? Depending upon the two types they are known. One is called as this configurational isomer, which may be subsequent optically inactive isomers. And other isomer is called as optically active isomers. You know there is something called polarized light. Whenever this light passes through a certain medium, the polarized light is angle is bent or the direction of polarized light is changed. पढ़ के आए हो आप लोग polarization, whether it is rotating the polarized light or not. If compound is rotating the plane of polarized light, it is called optically active compound. If compound is not rotating the plane of polarized light, it is called optically inactive compound. This ये जो दो लिखे हैं ना, they are nothing but they are optically active and optically inactive का ही example बोला है. Okay, so optically active, optically. Now let me teach you what is called optically inactive compound. Optically inactive, they are basically your this geometrical isomers. नाम तो सुना ही होगा. Examples are cis. Other example is trans. Third, it can be E. Fourth, it can be Z. These isomers are cis, trans, E, Z are optically inactive configurational isomers. So Z is Z is a geometrical optically inactive configurational stereoisomer. Cis is optically inactive configurational stereoisomer. Okay, तो optically inactive में भी ये geometrical isomer के नाम. They cannot rotate the plane of polarized light, but their configuration is different. Okay. Now we are coming to optically active chirals. Optically active compounds are further classified into two types. One of them which possess chiral center, other may possess chiral plane. Which possess chiral center are having chiral center. ठीक है, ये एक नाम तो आपने सुना ही है, what is called chiral. Okay. Other compounds which possess axial chirality. Okay. So two types of this two isomers. This is chiral center and axial chirality. Now let me show you first with chiral center. So these compounds which are having a chiral center. Taken a Wantoff and Libel were the first two scientists who discovered chiral center. That a carbon which is connected with four different valencies, that is called chiral center. ઘણા લોકો એવું પણ બોલતા હશે chiral carbon. That chiral carbon is nothing but this chiral center, but don't pronounce it as chiral center. Pronounce it as chiral center. Chiral is also some of the correct word. Chiral carbon is this kind of a carbon which is also connected with four different valencies: fluoro, chloro, bromo, iodo, methane. That is having a carbon, chiral carbon. Okay, so the examples of these chiral centers, and there can be capital R or can be capital S. You know what is called R, what is called S. It can be, let us say, dextro plus. It can be levo minus. Capital R, capital S. It can be third, capital L. Can be capital D. Dextro levo है ना, उसी को ही बोलते हैं small d, small l. These isomers are basically chiral center having optical activity. Fourth type is basically you might have heard the name of enantiomer. Okay, let me just increase this. Enantiomer can be diastereoisomer. It can be 6 can be meso compound, और although it is not optically active, but वहां पर भी आपको सुनने को मिलेगा racemic mixtures. All this belongs to this kind of optically. I cannot go further down, but yes, these all are these kinds of examples. Okay, R, S, dextro, levo, capital L, capital D, enantiomer, stereoisomer. So these meso compounds are having chiral center optically activity configurational stereoisomers. Enantiomers are having chiral center optical active configurational stereoisomer. तो वो जो आपके जैसे आपके नाम के पीछे आपके फादर का नाम और उसके पीछे उनके दादा का नाम और आपके दादा का नाम और उन आपके दादा के दादा आपके फादर के दादा का नाम. That way your ઘણા ગુજરાતીમાં છે ને બારોટ કરીને આવે. So ये એની પાસે બધા ડેટા હોય કે ભાઈ આની ફઈ ક્યાં આની બેન ક્યાં આનું 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 ક્યાં ક્યાં કઈ ફેમિલીમાંથી કનેક્શન છે એની પાસે બધા ડેટા હોય એવી રીતે આપણે ડેટા રાખીએ ને એમ ના ડેટા ફેમિલી બેઝ ડેટા કુળના કુળ નિધિ કોણ છે કુળમાં દેવી કોણ છે એટસેટ્રા. Here these isomers have their hierarchy belongs to isomers, stereoisomers, configurational isomers, optically active chiral center. So that way they differ from each other. Now I will go to the last class of this classification is axial chirality. So these molecules possess chirality across the axis. X-axis, Y-axis or Z-axis. X-axis may be like this, Y-axis is like this, and Z-axis is towards X, Y, and Z. So this way, molecules can have axial chirality also. What are these axial chirality? So among the axial chirality, there is something called this basically as yes, allenes. Allenes are the molecules which can have this kind of chirality. Allenes. Then it comes to biphenyls. I'm not writing here biphenyl. Biphenyl also these kinds of class. Then sorry, that one biphenyl. We can have another molecules which are called spirenes or spirenes. So they are having axial chirality. Okay, so this basically chiral center RSLD. This is a structural class framework. Axial chirality. Although मैंने थोड़ा मेरा ड्राइंग उतना अच्छा नहीं है जितना आप लोगों का होगा. This is a class stereoisomer. There are several types which we will cover in which we will learn in our coming class. And believe me, you will never find this classification in any of the reference book. This classification I have learned from my teacher who taught me organic chemistry in B Farm. I have never seen this complete classification in any organic chemistry book. Isomers, constitutional isomers, configurational isomers, then structural this having chiral center, without chiral center, optically active, optically inactive, acyclic, cyclic, I have never seen. This you will find only here in this session. So what are these different types of the isomers? That we shall learn in our coming class. So let us stop up to this. From next onwards in the coming session, we shall be discussing what are these key terms, their examples, and their different properties which we will learn in the coming days. Thank you everyone. Thank you so much.